where it's at. Tap on Properties of Logarithms answer sheet. Tap on that. Property, now I did this before your last quiz. And for some of you, it didn't go well. Tomorrow, there will be a quiz on, do you have it up on your screen there? Properties of logarithms. These have already been given back to you. 685, 5 to 15, 686, 19 to 30. You have your papers. Now, look at the first answer sheet. These are the ones where you just use those properties, you keep breaking it down, breaking it down, breaking it down until you can't break it down anymore. Now, don't do what happened before. Because I said, here's the answer sheet, and I'll give you those back at the end of the period. But some of you didn't do very good on that last quiz. Look at numbers 7 and 8. I'm just pointing this out because you'll see it in the quiz. See number 7 there on page 685, 1/4 log of 8 to the base 2. Do you understand why that's not done? Can one of you tell me? Look for this on the quiz tomorrow. I guarantee you'll see it. And number 7, see where it says 1/4 log of 8 to the base 2? Why isn't that done? See, that wouldn't be finished. Rob?
Because 2 cubed is
Because the
2 cubed is 8.
Because the log of 8 to the base 2 is 3. So 1/4 times 3 is 3/4. Same thing in number 8. Log of 9 to the base 3 is 2. So 3/4 times 2 is 3/2. And then all the rest of the problems is using the properties. And then if you look on page 686 on your iPad, swipe to the 3rd page. It'd be the 3rd one. These are the ones where you're using the same properties, but you're going backwards. You understand? So you get one single logarithm. That's all the quiz is on. The quiz has nothing to do with the stuff we've been doing with the calculator. I don't think that'll take you the whole period, but that's all we're doing tomorrow. So when you're done with the quiz, you're done until next week. Okay? All right. This is all we want to do here. Go to the handout now from yesterday. Example number 2. Have your calculator out. I only have a few things left to do here. We did example 1, we did example 3, we did example 4. I'm just going to finish the examples on this, and then I'm going to add, I'm just going to add a few more problems. You're going to add this to what I assigned yesterday. Then you'll turn them all in all at once. So go on the handout right here. You can't get the common base, so what do you do first? Come on, I showed you this yesterday. What's the first thing you do to this? We did example 1 yesterday. Example 2 is very similar. What's the first thing, Rob?
Make both logs.
The log on both sides. Okay, now fellas, you're writing on the handout. This is example 2. Okay, now what do you do on both sides? You use your power rule. Somebody tell me what to write down. Come on, I did this with you yesterday. Just watch, there's going to be something that's going to happen here. David.
Quantity of y plus 3 log 2 equals y log 5.
It's got to be grouped. So it's the whole thing times that. What are you trying to do here? Solve for y, right? Keep in mind, there's a y over there too. What did I tell you to do with this when there's a quantity? I showed you this yesterday. Andrew, or Ethan.
Distribute it.
Okay, now watch this. Somebody just take this log of 2 and distribute it by both of these. Tell me what to write right here. distribute it. Take log of 2 and distribute it times both of these and tell me what to put right here. Alex.
Y log of 2 plus 3 log of 2.
Equals y log of 5. Pay attention here. When you solved equations in freshman algebra, didn't you always get what was the thing that was set all the time? Variables left, constants right. This has a variable. This has a variable. What do you think you're going to do right now? Do just like you did in freshman algebra. Don't worry that these are logarithms. You still do the same thing. So if I said to you variables left, what are you going to do with that term right there? Come on, what's the matter? Just like freshman algebra. What are you going to do with this y log of 5? You're going to, Chris?
Subtract each side by y log of 5.
It's going to come over here, and it's going to become minus y log of 5. So drop this down. Now, pay attention here. This comes over, minus y log of 5. And now what's going to the right? Andrew, the handout from yesterday, just take it out. This is what we just started here. What are you going to do with this 3 log of 2? Max?
Bring it over.
It's going over there, and it's going to become negative 3 log of 2. Boys, pay attention here. Watch this. Come on, I need somebody to be really smart here. Look at the left-hand side. Come on. I need somebody. It's not a hard step, but what do you think I got to do next? It's such basic algebra from freshman year. You're trying to solve for y. Well, this has a y in it, and this also has a y in it. So what do you think would be a smart thing to do there? Oh, man. Isn't there something common to both of those terms? That was a hint. What do you think would be a smart thing to do right there? Max?
Subtract?
No. All right, you know what? Let me take back what I said. If I said, okay, go ahead, what are you going to do, Max?
Take the 2y and make it so it'd be negative.
Where do you see 2y?
The y log 2. Would you change that at all?
No.
Okay.
No, look. See these two terms here? They have something common. That was a hint. So what do you think would be a very smart thing to do on the left-hand side? Because both terms have something common. I mean, I practically am telling you what to do. It's basic freshman algebra. Nathan,
Take the y's out.
isn't y common, like a GCF? You're with me now, right? So if I factor out a y, what's left in the parentheses? Well, this is basic algebra right here. All I'm doing is factoring the y out, because it's common. Jack?
Log of 2 minus log of 5.
Log of 2 minus log of 5. And then this comes down. Okay, now you're almost there. You have one more step, and then your calculator is going to take over. You're solving for y. What do you suppose? Come on. Do the same thing like you did solving equations. What do you suppose I want to do on both sides? And I'll have y equals here. Come on, guys, it's not a hard step. I got y times that whole quantity equals that. I just want this to be y. Fisher.
Divide both sides by the quantity.
Did you hear that? Divide both sides by that entire quantity. Does someone have a question on that? If I divide both sides by the whole quantity, isn't this going to be this y equals now, which is what you're trying to get? So let's go minus 3 log of 2 over log of 2 minus log of 5 yesterday, we know what you can't do right now. You know, I don't wanna relive it, but you can't do that. That would be really bad. Right here, and here's the one thing, now with your calculator, now you all gotta do this, because if you don't do something right with the keystroke, you're not gonna get the right answer. On the top, you know, you're gonna go log of 2 times -3. Can everybody do that on your calculator? Just take the log of 2 and multiply it by -3. Do that. Okay, now listen to what I'm gonna say right now. You enter log of 2 times -3, and you're gonna have, well, you know what? Somebody, tell me what your display says right now. I wanna hear it. I wanna make sure y'all got this, the same thing. Just the top. Just the top. Take the log of 2 times -3. Somebody, give me that decimal. Just the top. Start.
-0.903.
Okay, so you got that on the top. Now you got to take all of that and divide by the entire denominator. So listen to me. It's what you have there divided by that whole thing. Not just, what I'm saying is, on your calculator, you got to make sure when you divide by that whole thing, it's grouped. Don't you got parentheses on your calculators? I believe you do. Now look, I need you all to do this because you got to make sure you're all getting the right answer. It's log of 2 times -3 divided by that whole thing. It's got to be grouped. If you don't group it, you're only going to be dividing by the log of 2, and then you're going to subtract. You ain't going to get the same answer. It's divided by the whole thing. Can somebody give it to me? 3 decimal places. You got to make sure you're all getting this number. It shouldn't deviate from anybody. Okay, Dodds.
2.269.
Okay, that's right. Now, are you all? Everybody should be getting that. If you're not, you're punching your buttons wrong. Do you understand what I'm emphasizing here? When you do the top, it's divided by this whole thing on the bottom. That's got to be grouped when you do that. This problem right here, I only got maybe about 10 more minutes here. I'm going to be done. That number 12 is going to be very similar to this. Okay, now, turn that handout over on the back side. Look at example 5. All right, I'm not going to say anything. It's really kind of an easy problem, but one of you, tell me what to do. Solve for X. I'm not going to say anything. It's based on what I did yesterday. You should be able to do that. Solve for X. What's the matter? Let me ask you this. Are you going to take a logarithm on both sides? Somebody answer that first. You know how over here I took the log of this side and the log of that side? Am I going to do that in example 5? Am I going to take a natural log on both sides? The answer is no. Why? Why would I not do that? Max?
One's already there.
One's already there. Thank you. So what are you going to do first? It's your property. Ethan.
Put the exponent in front of the natural log.
0.04x times the natural log of e equals the square root of 3. Now you should be on the back of your handout. And this problem's almost done already, isn't it? Somebody tell me something. Showed you this yesterday. What can you do up there? It's actually kind of going to drop right out of the problem, isn't it? Hint, hint. What can I do right there? What?
The initial e is 1.
That just equals 1, right? You all know why, don't you? Technically, that base is e, right, for natural logs, even though you don't see it. So this is 0.04x equals square root of 3. So what's x? Square root of 3 divided by 0.04. Go ahead. Punch it away. enter 3, hit the square root key, divide by 0.04. 3 decimal places. What is it? Calculator's going to do everything for you. What do you got? Square root of 3, it's going to be some decimal divided by 0.04. What do you got? 3 decimal places. Rob. 43.301. Now, one more thing. That's all I have. And then you're gonna add what's over there to that homework. Then you're gonna turn it in. All right? You still have plenty of time to get this done. Look at the directions for examples 6 and 7. It's going to be just look at the directions. Solve each equation. Give the exact solution. Do you know what that means? Do you know what that means you're not going to do? I'd like one of you to answer that first. It says give the exact solution. Do you want to know what that means you're not going to do? David? No. Give the exact solution. You know what that means you're not going to do? Quinn? You're not using this. You're not going to use this. When it says give the exact solution, look at these answers from yesterday and today. These aren't exact, right? You're rounding these to 3 decimal places. They're not exact. So look at example 6 and example 7. Look how they're written. You were already tested on this. This is that quiz you took earlier in the week. What's the first thing you're going to do on the first step in both of those? You already know this, fellas. See how fast you forget, though? That last quiz you took, the second 10 problems, you got the log of something to a base equals a number. You got the log of something to a base equals a number. What's the first thing you did to solve those kinds of problems? On the last quiz you took. What'd you do first? Nathan, you converted it to exponential form. So what does this mean? Doesn't this mean 3 to the 4th equals 5x minus 3? You with me now? 3 to the 4th equals 5x minus 3. How about over here? 2 to the 4th equals x plus 5 quantity cubed. See these problems right here? That's what these are going to be. Exact answers. That means no calculator for those. All right, my God, give me a break. This is pretty simple. What's 3 to the 4th? It's 3 to the 4th. Figure it out. Jack? 81 equals 5x minus 3. Take this negative 3, put it over here. 84 equals 5x. What's x? Coming out pretty easy, isn't it? Because it's linear. What's x? 5x equals 84. X is... You're not doing no calculator. There's no decimals here. Exact answers. Howard?
84 over 5.
That's an exact answer. You're not going to divide with your calculator and go to 3 decimal places. That's an exact answer. 84/5. Done. This one. All right, I'm just going to... All right, 2 to the 4th is 60. Let's just bring this down. We're almost finished here. In fact, I'm done right after this. And then you're going to add those to that assignment and then put it on my desk. What are you going to do? How are you going to continue that? What are you going to do to both sides? You have something cubed equals a number. You know this. You have something cubed equals a number. There's no calculator here. There's no calculator here. Oh, man. Look. I'm going to make this a lot easier. Here's something cubed equals a number. What are you going to do to both sides to finish it? Noah?
2 cube root.
cube root of both sides, right? Wouldn't this just be x equal 2? Okay, that has a quantity cube. So, take the cube root. Here, let me write it this way, because normally this would be here. Let me just do this. I just flip-flop sides. If I take the cube root of both sides here, what's the cube root of x plus 5 quantity cubed? What's the cube root of anything cubed? It's just that thing, right? What's the cube root of x plus 5 quantity cubed? John? X plus 5 equals, pay attention here. What am I going to do over there? Tell me what I'm going to do over there. There's no calculators here. Nathan?
Cube root it.
Cube root of 16. Watch this. Solve for x. What are you going to do with the 5? Fire it to the other side, right? So if the 5 goes to the other side, is it going to become negative 5? Plus, watch this. I'm looking right here. Freshman algebra again. Oh my God. Cube root of 16. Can you reduce the cube root of 16? Does 16 have a factor that's a perfect cube? So how did we do this? Cube root of, what did we say, 8 times 2? Remember how I did this? Indicate the perfect cube there. Should have visions coming back from 9th grade here. So what's the cube root of 16 reduced? Just pull out the perfect cube. Howard?
2 cube root 2.
Plus 2 cube root of 2. Now, look at that. That's the answer. You're not using a calculator there when it says exact answers. Okay, now you're going to have to go